Amanda Tulk, Chief Science Officer at Xstrahl, talks about why the cancer research world is embracing preclinical dosimetry.
Radiation therapy is based on the principles of cancer research that were established many decades ago. And whilst the technology in radiotherapy goes forward leaps and bounds, and we have the advent of MR-Linacs and flash radiotherapy coming into the clinical world more as a routine, we need to go back and have a look at the dosimetry. What do we know about the dosimetry is based on the radiobiology that we did. There has been a lot of debate in the radiocancer research world about the fact that when they irradiate their samples, whether it's in vivo or in vitro, that knowing the exact dose and the framework in which the cells or the specimens were irradiated is critically important to these outcomes, especially when we're looking at flash or looking at hyperfractionation. What we really need to understand is the difference between the normal tissue probability and also tumor control probability. These are really important factors. What we found when we look into the cancer research world is that some groups are really just doing what the previous researchers did, and the estimation on dose can have a big impact on their research outcomes. We see and hear this a lot, and at Xstrahl we're often called in to try and work out what isn't quite working. And when we look at this, a lot of the time it's the dosimetry. So in the clinical setting, dosimetry is checked weekly, daily, annually. In the cancer research setting, it's very hard for some of these groups to actually get physics support. So what we're looking at Xstrahl is how can we support them, or what can we put into our equipment that enables them to have a readout of the dosimetry, but also a better understanding of it. We also provide the ability to contact us to look at their experimental setups before they start. A common problem that we see is that people stack Petri dishes. Unfortunately, the radiation deposits its dose at the first Petri dish, and as it's absorbed, there'll be less dose at the bottom of the stack. By simply putting their Petri dishes all on the shelf together rather than stacked, we can alleviate that inhomogeneity of dose. When we look at the other specimens that can be treated, small animals, we really need to check that we're actually giving the dose to the midplane, to the flank, to the tumour, to whichever anatomical site they are expecting to do. Because if they think that they're giving 2 gray or 5 gray, and actually they're giving half a gray or 10 gray, that's going to have a massive effect on the outcomes of their research. Education, knowledge and support are how we are starting to make this change in the cancer research world. This initiative has been really well supported by grants with MC3R in the UK, but also work done in the US looking at standardizing how the radiotherapy dose and the methodology and how it's actually gone through quality assurance, make it into the peer review articles that become the basis of somebody else's next research concept.